So also I left you the 2.5 homework as well, 2.3. I had listed a few formulas or theorems, so just a little bit more on section 2.5, convex polygons. Okay, so I gave you some definitions and a definition of a diagonal and some different shapes. They're in your book, but the formulas that I gave you that I want to highlight is the number of diagonals of a polygon of n sides is equal to n times n minus 3 divided by 2. So this is the number of diagonals of a polygon of n sides. So that's one formula that you will need to know. Okay. I also gave you a formula for the sum of the measures. So the sum of the measures of an n-sided polygon is equal to n minus 2 times 180 degrees. This is the sum of the measures of the interior angles of an n-sided polygon. There's a formula that I gave you also in class. Now there's one more formula that I did not give you in class. I did ask you to look at it, and I'll go ahead and give it to you now so that you can continue to work. Well, I talked about a regular polygon. First of all, let's just remember that definition. A regular polygon is a polygon that is both equilateral, congruent sides, and it has to be equilateral, and it has to be equiangular. And remember, that is congruent angles. And so then the last formula that I want to give you is the formula, the measure of an interior angle of a regular polygon. Okay, the measure of the interior angle of a regular polygon. Well, we know that the total measure, the sum of all the angles, is n times 180 degrees. But then all the angles are the same, have the same measure, so we just divide that by the number of angles we have, which is n. Okay? This is the interior angle measurement of a regular, now that's important, it's only for a regular polygon of n sides. So there's one more formula that you might need for your homework. There's a corollary that follows as well, and a few examples.